It's time to look at naming ionic compounds with what are called polyatomic ions. So up till this point, we've only worked with binary compounds. A polyatomic ion is essentially a molecule that has a charge. Most of them feature one or more oxygen atoms along with some other elements, and you can recognize their names because they end in "ite" or "ate. They're in this little chart on the back of your periodic table. As with all other ionic compounds, the formulas are always written cation followed by anion. So let's have a look at this as an example. So what's the name of the cation Ca? Well, that's calcium. Calcium has a 2 positive charge. It always does. So then I notice NO3. That's in brackets because what I'm saying is there's 2 of them there. I'm going to go to my chart and I'm going to find that name of that anion. That anion is called nitrate. And I notice that each nitrate has a charge of -1. Write the name, calcium nitrate. Okay, you don't need to adjust the suffixes or anything. Well now, what about if I want to write the formula for a compound with a polyatomic ion given the name? Let's look at this one, gallium sulfate. Cation and anion. Gallium has a charge of 3 positive, sulfate has a charge of 2 negative. So just like we've done before, I've got to find enough galliums and enough sulfates such that the overall charge on the compound is equal to 0. So in playing with the charges, I notice that if I have 2 galliums and 3 sulfates, plus 6 minus 6 equals 0. So the overall formula for the new ionic compound is Ga2 and then in brackets SO4 with a little 3 outside of them. So let's look at another example. Now, what about one that involves a transition metal? So the transition metals have multiple possible charges, but notice the charges on the polyatomic ions never change. So let's use that charge to determine the charge on the transition metal. So here I have a formula, cation, anion. Chromium has multiple possible charges. The overall charge on this compound must equal 0. P2O7 negative is called pyrophosphate, and the formula has 3 of them. So the total negative charge is -12. That means the 2 Cr ions must bring +12 in total, meaning that each of the chromiums must have a 6+ charge. The name of this compound is chromium 6 pyrophosphate. Okay, remember the Roman numeral in the name corresponds to the charge on the metal ion.